About locking down Azure Synapse Analytics. As Kevin mentioned, my name's Kevin Feasel. I run a predictive analytics team out of Durham, North Carolina. I'm a data platform MVP, and I have a blog called Curated SQL. The idea of Curated SQL is I try to find and link to 5 to 10 interesting posts per day on topics all across the data platform space. So check that out, curatedsql.com. What we're going to do today is I probably will not have an opportunity to breathe because we're doing a high-level overview of Azure Synapse Analytics security. And when I say high-level overview, there's a lot to this product, and so we are going to have to keep it high level. But we will talk about what we can do with network security, with workspace security, outside resource connections, securing dedicated SQL pools, the serverless SQL pool, Spark pools, and I'll give you some notes on additional tooling. There's one pool that I'm going to talk about that we're not talking about. But before I get into that, let me set some expectations and say, hey, wait, what is Azure Synapse Analytics? Just so we're all on the same page. This is Microsoft's platform for modern data warehousing. So there are 4 major data sources. I mentioned 3 of them. Dedicated serverless SQL pools, Spark pools. There's also Data Explorer pools. They're in preview. Because of that big word preview, I'm not going to talk about them today because we're doing a security discussion and who knows what's going to change between the time it's preview and GA. Probably some security stuff will change, so I don't even want to waste your time on that. Let's focus on the 3 that are generally available, and trust me, that'll be enough. Dedicated SQL pools used to be called Azure SQL Data Warehouse, derived from Parallel Data Warehouse and APS on premises. It's a massive parallel processing approach for data warehousing. So it's going to work best if you have Kimball-style facts and dimensions. If you have a proper star schema warehouse containing at least a terabyte of data. Yes, you can use less than a terabyte, but if you have a lot less than a terabyte, this is probably not going to be very cost efficient for you. You want to have generally at least 1 billion rows of fact data, just to give you a rough idea of where this begins to pay off. Spark pools are implementing Apache Spark. Apache Spark is an open source project based in the Hadoop ecosystem, allowing for massive distributed processing in memory. Good for complicated data transformations, the kind of stuff that SQL doesn't necessarily do very well, could be rather efficient in Spark. And one of the niceties about integrating Spark along with dedicated SQL pools and the serverless SQL pool, we can switch between languages. So we could do one component in Python or in Scala, and then another component in T-SQL, and take advantage of the best of all of these different systems. This is also good for distributed machine learning activities. And also if you have on-premises Spark clusters, or if you're using HD Insight, it's a good migration point. If you're very familiar with Databricks and you like Databricks, probably stay with Databricks. But that's a discussion for another day, because really this is just telling you what, because we need to talk about security for it. I also mentioned the serverless SQL pool, and the serverless SQL pool is a little bit different from a dedicated SQL pool. There is one serverless SQL pool, and it does not store data. I had a DBA manager, and we joked about how his idea of the best database was the one that didn't have any data in it, because then that database was really fast. Like all the tables, you could query them instantly, just no data in there. And the serverless SQL pool might be right up his alley because you don't store data in them. Instead, they actually read directly from the data lake, which means that they are sometimes kind of slow. But you can read from your data lake using T-SQL. It's actually a really cool technology. And the pricing model is rather effective. It's $5 per terabyte scanned. There are several good use cases for the serverless SQL pool, especially around ad hoc exploration of your data. And visualizing and virtualizing what your data lake looks like in a structured fashion. Data Explorer pools are built off of Azure Data Explorer. And think of it as logging tables. Think of it as time series processing of data. If you are familiar with Splunk or with Datadog or one of the other SIM type tools, the Kusto query language, KQL, is actually pretty similar to Splunk's querying language. But again, these pools are in public preview, so we're not going to talk security about them because that stuff's liable to change. Very brief pool advice before we move on. You only get one serverless SQL pool. You get no more, no fewer. You can't delete it. You can't create a new one. Use one Spark pool per relevant task, which is also a good idea for security. If you have different teams working with Spark, they should have different Spark pools. That way you can separate out resources more efficiently. Create and destroy those Spark pools. They are cattle, not pets. You don't want a Spark pool running 24/7 and accessing it like you might a dedicated SQL pool. This is a thing that you just want to be there for however long you're processing and then throw it away, because when I need it again, I'll just create a new one. One dedicated SQL pool per warehouse. This one, pet, not cattle. You're not going to tear apart, rebuild dedicated SQL pools very often, but you can pause them when you need to save some scratch. If you have any questions at all, definitely hit us up and I will respond to all of the pools. Yeah, definitely all of the pools. In addition to all of the pools, we have Synapse pipelines. They're based on Azure Data Factory. The underlying code base actually is the same, making it easy to do extract, load, transform. And not enough, Synapse Link. Link allows you to connect data sources into Azure Synapse Analytics. The first deployment of this was Cosmos DB. So there was Synapse Link for Azure Cosmos DB. There is now Synapse Link for Azure Dataverse. And recently announced was Synapse Link for SQL Server 2022. I would expect that there will be more Synapse Link connections as time goes on. The idea here is I want to be able to link a external service like SQL Server 2022 and load data into my dedicated SQL pool without having to build those Azure Data Factory or Synapse pipeline jobs, without having to do a lot of ETL work. Just let me make a connection and then pull data from that table. So that's the premise. Okay. We know what Synapse is. We get an idea of what its scope looks like. And now we're going to create our own workspace. But before we get there, we've got a couple of things to talk about. First one is regulatory compliance. You may have a variety of regulatory regimes that you've got to worry about. And Microsoft's compliance documentation is a good place to go to understand, based on your different compliance regimes, what resources may be available to you and what resources are not available to you. Not all Azure services are compliant with all of the different regulatory regimes. So, for example, if you have to be FISMA compliant. Oh, you know what? I may have misspelled FISMA, but whatever. Let's pick one here, DoD IL2. And in this case, this is going to give you an idea of what's in scope. So these are the resources that are in scope for this compliance. And it'll give you an idea, for example, of what you can use. Like, can you use commercial Office 365 or do you have to use the government cloud? So this gives you a brief overview of what is available and what is not available. It sort of acts as a starting point. Compliance is a two-way street. Microsoft will make things available for compliance, but technically you are also relating to compliance. So, for example, Microsoft controls the hardware. You're not controlling that hardware. So they have to do those things for PCI, for HIPAA, for SOC that will enable you to control access and to control what data is stored where, how is it stored in order to be compliant. They may offer encryption. They may automatically encrypt certain resources, but you can also control the encryption using customer managed keys or pre-encrypting your data before moving it into Azure into something like blob storage. Microsoft will control networks, but you control maybe who gets access to the networks depending on the service, and also you control the data. What information gets stored, what information gets saved, what information gets retained, and for how long and where. Speaking of data retention, this is a key element of any regulatory regime. We definitely want to encrypt data when it is sitting at rest and also in transit. And we'll want to ensure that within Synapse, data that's at rest, data that's in movement is encrypted at rest using disk encryption, using whatever encryption mechanisms we have available to us, in transit by requiring TLS, ideally TLS 1.2. We want to make sure that any sensitive data is actually necessary, because if you store that information and it is sensitive, you now have a risk. There's a risk of data breach, and now you've lost sensitive information, which could lead to fines, could lead to serious issues. If you don't store that information, you can't lose that information. It's that's galaxy brain thinking right there. We also want to make sure that we remove obsolete data and grant access as it's needed. So these are really high level, a little bit of well duh, but good to think about as you are architecting your Synapse solution. When it comes to business continuity, Microsoft is going to control most of the high availability in Azure Synapse Analytics. So dedicated SQL pools, they are distributed. They are highly available by default. If a server fails underneath, they'll spin up another one. They'll have it available for you. So because compute and storage are separated in the Synapse world, it's pretty easy to have more compute available to handle a failure. The serverless SQL pool also highly available, though the service can fail. Despite it being highly available, you may run a query and it will fail because a service is down. Usually what I found is, yes, it's down, but I run it again in 2 minutes and it's back up again. It does happen on occasion. Spark pools, a little bit of user controllable high availability in the sense that, oh, this thing failed? Fine, trash it, start a new one. On the disaster recovery side, this is where we have a little bit more to say. All of that stuff for high availability, nothing really that you or I could do to make it more highly available or less highly available within the context of reasonable activities. You could technically have multiple Synapse workspaces, store your data in a whole bunch of different spaces, and have people access all of them. I suppose, yeah, you could do that. It costs a lot of money and take a lot of effort, and I don't know if it would be that worthwhile, but I suppose it's possible. With disaster recovery, more of a joint effort. Dedicated SQL pools are going to take automated snapshots roughly every 8 hours. As long as your dedicated SQL pool is running, the automated snapshots will run about 3 times a day. It will retain your data for 7 days. At any point, you may take manual snapshots. So if you pause your SQL pool overnight to save some money, you may wish to take some manual snapshots on occasion. So have a service that just runs a manual snapshot every day or two, just to make sure that you have one. Because if the pool is paused for a long time, the automated service may not actually get triggered during the time that you're up. Dedicated SQL pool snapshots are backed up to another region every day. which means worst case, you lose a day's worth of data because at least your data is in some other region. And the other pools, the Serverless SQL Pool, the Spark pools, they store data in a data lake. You don't actually store data in the pools themselves. So you're worried about Azure Data Lake storage at that point. And this is where you have options: zone redundant storage, geo redundant storage. I would recommend geo redundant storage for production. It's going to cost a bit more, but it will make your data lake disaster recoverable. You'll have it in multiple regions in case of failure. Now, we talked a little bit about things to think about on the architectural side. Let's look at some setup options. And there are two options around network security. The first one, manage virtual networks. The second one, data exfiltration protection. Both of them are actually available on this little screenshot here in the networking tab of creating a Synapse workspace. Managed virtual network, the little radio button right there. Almost always, I'm going to recommend you enable it. Approve or allow outbound data traffic only to approved targets. That's data exfiltration protection. I'm a lot more ambivalent about this one. So let's talk about what these mean. The managed virtual network is a virtual network that Microsoft manages for you. You have to enable it at creation time. You cannot switch it on after you create a workspace. You cannot switch it off after you create a workspace. If you decide later on, I made the wrong choice, you have to recreate that workspace. Meaning, good thing to think about before you get started. There is no option for you to create your own virtual network and manage Azure Synapse Analytics through it. So if you really want that opportunity, unfortunately, it's not available. The options are Microsoft controls it, or you don't have a virtual network. It's just public cloud. In case you're not familiar, what is a virtual network? A virtual network is Microsoft's way of essentially segmenting out resources in a network and allowing you to control access to those resources, including whether or not they are accessible directly from the public internet. The virtual network is going to allow you to make it so that, for example, your Azure SQL database is not publicly accessible, but that your web servers can hit it, or that people who are remoting into a virtual machine using Azure Bastion can access your database, but some rando on the public internet cannot. This is quite different from setting IP address-based firewall rules. That's another topic altogether. This is about managing collections of subnets and what resources are available within those subnets. Just kind of what I'm saying in this slide. All right. What does a managed virtual network actually provide you in the context of Azure Synapse Analytics? Well, number one, any Spark pool that you create will be in its own subnet, guaranteed. What this means is if Team A creates a Spark pool, Team B creates a Spark pool, those Spark pools cannot communicate with each other. I cannot jump from one to the other. That's a good security measure, because if Team A has an exploitable package that they've installed in their Spark pool and somebody from the public internet is able to get into that Spark pool somehow, they can't then laterally move to another Spark pool. Next, the Synapse workspace itself is in the managed virtual network. The dedicated SQL pool, the serverless SQL pool, those endpoints are actually not in the managed virtual network. But what we do is we create something called managed private endpoints. These are connection points to Azure resources that don't transit the public internet. So, for example, the serverless SQL pool, the dedicated SQL pool. If I have no managed VNet, I can access those directly from the public internet. I can connect from my PC, wherever I am, hit whatever Azure region, access, if I know the URL or the IP address of that endpoint, I can query, and assuming that firewall rules are set up, I'm able to access it directly. If you enable a managed virtual network, the managed private endpoint says, okay, communications from the workspace to that dedicated SQL pool will never transit the public internet. It stays entirely in Azure networks. And what that means is people on the public internet aren't going to be able to try to capture traffic between the workspace and that dedicated SQL pool, or the workspace and Azure SQL Database, or Azure Key Vault, or Data Lake Storage, or Cosmos DB. Any resource that supports a managed private endpoint is going to be able to prevent that traffic over the public internet. And if you have managed public endpoints, you may enable data exfiltration protection. So DEP, one of its prerequisites is that you must have managed virtual networks. I don't think there are really any downsides to using a managed virtual network. I think it's pretty much all upside. At least I haven't thought of a really strong downside for it compared to you have no virtual network at all. Data exfiltration protection can work well, quite limiting the developers in practice. Again, this is something that you enable at creation time. You cannot turn it on after the fact. You cannot turn it off after the fact. You make a mistake, start over. Wipe and start over. So what does this thing do? It is going to limit the way that external resources can access your pools and how your pools can access external resources. As an example, Spark pools quite often are going to hit the public internet because I have Python and I'm installing packages through pip or through Conda. Maybe I have Scala and I'm installing packages. Perhaps I've installed Maven and I'm going to install packages that way. I have a script that goes and accesses some public information and pulls that data in. If you turn on data exfiltration protection, none of that works. You cannot access the public internet from your Spark pool. You cannot access the public internet from your dedicated SQL pool, from your serverless SQL pool. You may access things over managed private endpoints, things that stay on the Azure network. And you can even limit further and say, I'm only going to allow certain Azure Active Directory tenants to which I may write data. So the idea here behind data exfiltration protection is it's going to prevent some rogue operator within your company or some attacker who's found access to a Spark pool from taking your data, writing it out to their own S3 bucket, writing it out to Pastebin, writing it out to some other resource. That's the key concept behind DEP. It is very limiting in practice. It is something that if you have to turn it on, please do understand the consequences of turning it on, because it may be that your environment requires it. And if so, there are workarounds. It's just very annoying as a developer. Sticking to managed virtual networks. You can disable public network access all around. Okay, in the case of a managed virtual network, what happens if we don't have ExpressRoute or a VPN solution? Well, that's a great question. If you leave this radio button enabled, public network access to workspace endpoints, then public internet can still access. In that case, the major benefit is that when you're working within the Synapse workspace, then from workspace to resources is definitely secured. But public randos can still access potentially your workspace resources. Let's go one step further. Let's turn that off. What happens if we turn it off? Well, if we don't have ExpressRoute, we don't have a VPN, we could still use Azure Bastion and have a virtual machine and allow that virtual machine to access the Synapse workspace. You can lock down the workspace to just specific virtual networks. And you could say you have to be coming in from one of these resources in order to even see this workspace. By default, that's not true. You can access it from anywhere on the public internet. It does take some effort to set that up. It's a little outside the scope of what I'm going to talk about here today, but it is a possibility. I would consider that a more advanced bit of Synapse security, but still possible. So if you do have ExpressRoute or VPNs, then ExpressRoute's not really going to do too much here. The VPN solution is going to do a little bit more in terms of giving you a capability if you need to get to a jump box that can access the workspace, or to access the workspace directly using the point-to-site or site-to-site VPN. Now, suppose that what I just said, the last couple of sentences, made absolutely no sense at all. That's all right. You can also set IP address rules. This probably not what you want to see in production. You want to lock that down to just the IP address ranges that you know are valid. And in the event that you have turned off public network access, this rule doesn't matter too much because you're controlling that network access elsewhere. So if you're not controlling virtual networks, if you don't have ExpressRoute, you don't have VPNs, you could still leave this enabled, even with the managed virtual network. You could set your firewall rules for IP address ranges based off of what your valid addresses are and go with it that way. It's not a perfect solution, but it is a reasonable solution. One other thing to note is that there's a checkbox to allow Azure services and resources to access this workspace. This is what I will call the lazy person's way out. You could check this box and it will solve a lot of problems for you. However, in the process of solving a lot of problems for you, it is going to create a lot of problems in the sense that this box doesn't say just your services. This box says all Azure services from all subscriptions anywhere in the world. Not a great thing for security, but not something I would check necessarily. But we do see it a lot because, I can't figure this out. Fine, I'll just check the box. That'll solve my problem. Yet technically it solves your problem, but it creates a new problem in the process. The more proper way to do it is understand how things like managed private endpoints work, set up those endpoints, get service connections correct, instead of just checking the box that says, yeah, let the whole world, let anything in Azure in and it'll be fine. Let's talk a little bit about workspace security. For a person who you want to grant access to Azure Synapse Analytics, you are almost definitely going to want to access or grant them storage blob data contributor as a role assignment in that data lake. Azure Synapse Analytics requires that you have an Azure Data Lake Storage Gen 2 account. And in that Gen 2 account, in IAM, you're going to want to add these people as storage blob data contributors. I would probably create an Active Directory group in Azure to handle this, put people in the AD group, and let it go that way. Many things that you want to do are going to require this blob data contributor. Basically, anything that involves writing data and some things that involve reading data will need the contributor. Then within Azure Synapse Analytics itself, there are several role-based access control roles. These are what I'll call workspace level roles. And they're going to control the actions that users may take from the standpoint of Azure Synapse Analytics itself. There are additional roles that we will talk about within each of the pools, but think of this as your ticket for entry into Synapse. And the first role is Synapse Administrator. Basically, you get carte blanche for a whole bunch of stuff. Only Synapse administrators and owners of the workspace in Azure are allowed to assign RBAC roles to others. Nobody else may assign RBAC roles except Synapse admins and Azure resource owners. Not the subscription owner, the actual one of the owners of the Synapse workspace in Azure. If you are a Synapse admin, you're still going to need the appropriate Azure permissions, owner or contributor on that workspace for any kind of compute resource management. So you have Azure level roles, you have workspace level roles, and then we'll have pool level roles. If we disable public access and don't check allow Azure services or resources to connect, will Azure VM still connect? You would want to make sure that you had the virtual network set up appropriately. You would need to set up the workspace to be available within that VNet. There is a link. I will try to dig it up and post it in chat at the end here. So you would want to set that up first and then disable. Now, the good news is that you can still, through the Azure portal, re-enable if you mess something up. So you're not totally lost in that case. But there is some setup work that's involved. Spark admins create and manage Spark pools, but you can't run Synapse pipelines. You can work with Spark notebooks, and Synapse pipelines can run Spark notebooks, but a Spark admin can't run a Synapse pipeline. A SQL admin, you get full access to that serverless SQL pool. You can manage dedicated SQL pools. You can manage scripts, credentials, linked services in those SQL pools. Again, cannot run Synapse pipelines. Artifact is a very pretentious term, frankly, for within Azure Synapse Analytics. Artifact just means thing that I can save. So an artifact publisher, person who can save. I can save scripts. I can save notebooks. They can read and manage published code artifacts. Does not actually give you permissions to run the code. So you can have an artifact publisher who's not able to run the scripts that they're saving. Obviously, you wouldn't really want to do that, I don't think. There's also an artifact user role that will let you read the scripts. So you may be able to read something and run the code, but not save it. You can read it, but not run or save it. You can read it and save it, but not run it. Or you can read, run, and save, which is probably going to be most people. Credential users. These are people who are going to be allowed to use secrets. Those are within credentials or linked services. Linked services, a topic I'm going to talk about in a moment. But we're going to need credential user to do most anything with pipelines. Synapse pipelines use credentials. We need to be able to access our data sources. So you need credential user to be able to access those data sources. Compute operator. This is the person who can run a pipeline. And they can also actually run Spark jobs and run notebooks and cancel Spark jobs from any user. So don't just give compute operator to everybody. Give it to people who you can trust won't go canceling everybody's Spark jobs because they feel like it. Synapse Contributor. This is different from that storage blob data contributor. This is compute operator plus access to Spark pools plus integration runtimes. And you're allowed to work with published code artifacts, but you need to be an artifact publisher to actually save them. And you're also going to need credential user to actually run a pipeline. So if you have somebody who wants to run Synapse pipelines, you got to be a Synapse contributor plus a credential user. Those are separate roles. So compute operator has this set of roles. Synapse contributor has everything in compute operator plus a few more, but I also need credential user to really run a pipeline. Synapse user is I just kind of want you to be able to access things, but don't trust you to do anything for real. or I'm going to give you some very specific rights later. So Synapse User is your entry line, almost like a guest. And you can create new artifacts, but you are going to need permissions for the others, for pretty much anything else. So that's thinking about roles. And I hit you with roles. There's actually some really nice documentation for Synapse around how you can deal with those roles. And so I have a link to that later on that I'll provide you. Let's talk about data in transit. All traffic to Workspace endpoints is going to be encrypted using TLS 1.2. Doesn't matter if you're using a managed virtual network. You cannot access Workspace resources in Azure Synapse Analytics without TLS 1.2. You don't check a box, you don't uncheck a box. It's mandatory, which is good. Then that's the correct default. You don't want non-TLS access, and you don't want 1.1 or 1.0. So this is a good standard practice for data transit. I mentioned linked resources or linked services. Let's talk a little bit about what those are and what it means for managed private endpoints. A linked service is really just some connection to an external resource. That external resource could be in Azure, an Azure SQL database, or blob storage, data lake storage, Cosmos DB. It could be in another cloud, Amazon S3, RDS, could be on-premises, on-prem file system, or on-prem installation of MongoDB. There are dozens or maybe over 100 separate linked service connectors that are available to us on-prem, in Azure, in other clouds. When I say other clouds, it's almost all Amazon with a little bit of Google. For Azure services, we can connect using something called the managed identity. The managed identity is created for Azure Synapse Analytics and sort of says, I'm going to work as Azure Synapse Analytics without having to create special accounts in Azure Active Directory. This is a minimum permissions account that we're able to grant access to gather information from other resources. And we want to store any of those keys or connection strings in Key Vault. Key Vault is another linked service we can connect to. So we can have those keys stored in Key Vault. We can have certificates stored in Key Vault. Any secrets that we need stored over there. Key Vault is a really good storage mechanism and guarantees that you're not going to store credentials, plain text, or in an area where an attacker who has access to your physical machine will be able to see the unencoded credential. So it's a good practice in general. Private endpoints, managed private endpoints, as mentioned, use managed virtual networks. This is our way of connecting to Azure resources without transiting the public internet. Only works for a few resources. So if I look at the previous screenshot, you can see that scroll bar is pretty small. It's only about yay big. And if we go to the next screenshot, you can see that the scroll bar is much bigger. There's about 15 or so resources that you can access through managed private endpoint. If one of the resources you care about is available through a managed private endpoint, I highly recommend that you use it, because this is, again, going to prevent any public internet transit, which means that in the process of getting to your Key Vault or to your Azure Machine Learning service or to your data lake storage, in the process of getting data from there or to there, we're never going to be snoopable from somebody on the public internet. So it's a nice advantage. It takes a little bit of time to set up, and it does require a few steps in Azure to enable on both the Azure Synapse Analytics side and then also within a setting in your separate resource like in Key Vault or in Azure Blob Storage to allow that linked connection to occur. Once you get that managed private endpoint set up, it's golden. It just works. So it's a one-time setup cost, basically, in terms of your time. The trickiest part is different resources have slightly different places where the private endpoint information lives. Like sometimes it'll be in a networking menu. Sometimes it'll be in a security menu. It'll sometimes say private endpoint. It may also say like connection or some other phrase. And so understanding exactly where it is, frankly, is the most time-consuming part of it. We are now going to talk about pools. Pools and tools. So let's start with the dedicated SQL pool. The dedicated SQL pool has several things that we can use to secure access, in addition to what we've talked about already. So we've talked about kind of general principles around network security. There's not a huge amount that we can do there, but we can turn on managed virtual networks. We can eliminate public internet access to the workspace. We talked a little bit about Synapse roles. Those high-level roles are going to be necessary for subsequent processing. Now we're getting into, I've built a dedicated SQL pool. What can I use to protect my data? Well, there are role-based access controls within your dedicated SQL pool. And we know about these because they're basically the same as what we have in SQL Server on premises. We have logins, we have users, we have built-in and custom database roles. Some of those roles are a little bit different in the dedicated SQL pool than they are on premises, but many of them are going to be the same. DB data reader, DB data writer, DB owner. These sorts of roles have effectively the same rights in the dedicated SQL pool as they do on-prem. You can control access to specific objects. You can grant, revoke, or deny permissions to specific objects, to users or groups. And just like on premises, you can have Azure AD groups to which you grant rights. You may have database roles to which you add logins, or excuse me, to which you add users, and they will have rights. You may grant rights specifically to a user within a database. But as you control permissions, a couple things to remember. Permissions are inherited. So in other words, if I am in a role of Synapse people, then I get all of the grants and the denials from Synapse people. So if we grant Synapse people access to tables A, B, and C, and we deny access to table finance or to salaries, then as a Synapse user or one of the Synapse people, I don't get access to salaries or to finance. Revoke is going to reset a grant or a deny. So let's say, well, shoot, we actually do need Synapse people to see the finances table. Okay, we can revoke that deny, and now people in that role are able to see it. The tricky part, deny supersedes a grant, even if that denial is at a different level. So what do I mean? Well, I mentioned Synapse people denied access to salaries. Let's say I am a Synapse people, but I really need access to salaries, and the rest of Synapse people don't need access to salaries. The problem is, even if a DBA explicitly grants me access to salaries, the denial takes precedence. Meaning, if you have any denial in the chain of roles to which I belong, I'm not getting access to that table, no matter how many times you explicitly grant me, the user, select on that table. So something to keep in mind. A reason not to have really deep inheritance chains for roles. But again, this is the same on premises as it is in dedicated SQL pool. So the processes and methods that you use today probably going to work just fine with a dedicated SQL pool. Database roles have roughly this one-to-one correspondence within user databases. Within the master database, things are a little different. You don't have sysadmin, for example. Not going to get sysadmin. But you do get 3 master roles. One is DB manager. That's going to let a person create and drop user databases. DB exporter, create tables, alter schemas, work with Polybase. Reason that you need it for working with Polybase is I have to be able to create external tables and drop external tables. So you would need DB exporter. Login manager, create and delete logins in master. All 3 of these are pretty powerful roles. These are not the types of things that we just want to grant willy-nilly, but they may be necessary for certain classes of user. So important to keep that in mind. When it comes to storing data at rest, we talked about data in transit. We don't do anything. It's encrypted. We're good there. Data at rest. Well, dedicated SQL pools are always encrypted at rest using Microsoft keys. If your data is stored in a dedicated SQL pool, it is encrypted at rest. Those disks are encrypted. In addition, you may use a customer key to double encrypt your data. You do not replace Microsoft encryption. Instead, you encrypt on top of Microsoft encryption. That's fine. It doesn't have any real effect on performance. What it does have an effect on is that now you're managing customer keys, and somebody at Microsoft couldn't steal your data and decrypt it. They would need your key as well. And your key is stored in a key vault that they would need some serious access. Like, I don't even know if they have the capability to get that access. But in the event that some disks get stolen from an Azure data center, you're going to be fine. Even if they somehow get the Microsoft keys. If you're using customer encrypted keys as well, then you'll be fine. If you do not double encrypt your workspace, you may turn on transparent data encryption. You probably do know of transparent data encryption from on-premises. I have a love-hate, mostly hate relationship with transparent data encryption, but it is a possibility for a secondary form of encryption of your data that is stored on disk. So this would be in addition to the disk itself being encrypted. Also, any snapshots they take written to encrypted disk. So all data in the dedicated SQL pool, encrypted at rest, encrypted in transit, may not be encrypted in memory. So what we may do there is use column level encryption for that really sensitive data, for those, say, identifiers, the personally identifiable information, for very specific info that we don't trust even in memory. And you can perform column level encryption using encrypt by key and decryption with decrypt by key. This has been in SQL Server for actually a long time. It's been, I think, since at least 2000. If you do choose column level encryption, though, be sure to use AES 256 as your symmetric key. You do have options in Azure Synapse Analytics, AES 128, AES 192. Current recommended practice, use 256. It is good. It is still valid. It is still effective. On premises, because this has been around for so long, they support things like RC4 and DES. Don't use that on premises, please. It's not effective. RC4 is, in security terms, RC4 is a joke. It was actually still kind of a joke 20 years ago, but it's definitely a joke today. DES, even triple DES. No, please don't use that. AES 256. In Azure Synapse Analytics, you don't even get those options, which I think, again, is a smart choice. For backwards compatibility on premises, they support DES and triple DES and RC4, but not in Azure Synapse Analytics. One note, if you are a big fan of always encrypted, not supported in a dedicated SQL pool as of today. Will it be later? I don't know, maybe. But if you want encryption of your data at the column level, this is your way to do it. And the way that you would do this is you're going to create a master key for your database, and you'll create a certificate off of that master key. Or excuse me, you'll create a certificate. Then we create a symmetric key encrypted with that certificate. So actually, yeah, the certificate is based off the master key. The symmetric key is based off the certificate. And then we add an encrypted column. So a var binary column. And I can open my symmetric key using that certificate and use encrypt by key on the personnel key to be able to take the person's last name as text and turn that into var binary. Here I've got 160 bytes. And then I can query that data later by opening the symmetric key and using decrypt by key, sending in the encrypted column. It knows what certificate was used for encryption. That's stored as metadata in the table. And will allow you to convert that result to in varchar. And now I have my last name decrypted. So I can encrypt, I can decrypt using those functions. It's a little bit of effort for a developer, but it does ensure that even when that data is in memory, even when the pages are being read, it's encrypted. Meanwhile, something that is not a security measure, dynamic data masking, not an alternative to encryption. This is going to effectively prevent shoulder surfing attacks. If I have somebody who's looking over my shoulder as I'm running a query and maybe looking for a social security number, dynamic data masking can mask the results of the select and prevent them from getting a social security number. If you have ability to query the data, you can get around dynamic data masking. It is not a security measure. It is absolutely not an alternative to encryption. Row level security is a security measure, and this is going to allow you to use group membership or user membership or some identification, some information to control what rows appear in the data. So those are called filter predicates. Let's say we have a column in a table, region ID, and based on my group, I'm allowed to see data from a specific region. I can use row level security to create a security policy that ties that region ID to a function that determines, based on my group membership or some execution context details, my login, my user, my groups, my roles, whatever, whether or not I'm allowed to see that row. This is going to have a performance impact. We have to execute this function on all rows to see which rows are valid. So even if you only get back one row, you may have ended up scanning a lot of rows to figure out which one was the one. And those scans, that function, it may be just a few CPU cycles, but it can add up over time. So definitely will have a performance impact. Okay. Let's say we have some baseball data, and we're going to allow different baseball teams to get access to our data just for their team. So I've created a login for one team, and then I create a user from that login. That user is allowed to see the pitching table. So we're going to have some details on pitchers, and maybe it's some sensitive information, and we have it for each team. I also have another person, so as you can see, I can use Azure Active Directory accounts for this as well. I could have groups, roles, whatever. Then I create a function. That function takes the team ID and says, if the team ID is the first three letters of the username. So, I had ATL. If I take ATL and if that's the team ID, then I'm going to return 1. Or if the person's name is Alicia and you're in one of these 3 teams that's eligible, then I'll return 1. So we can have this be as complicated or as simple as necessary, understanding that it's going to run once for every row. So it's going to be a little slow. But we create a security policy. Our predicate that I created here, this is the predicate. This is the policy. We're going to say on the pitching table, the team ID column is the one that we apply this predicate to. And then when somebody selects from the pitching table, they will be able to see just the rows associated with their user. So ATL user can see any rows where the team is ATL. Alicia can see any rows where the team is one of the three that she has access to. This is pretty powerful, but again, I keep reiterating, it's slow, it's slow, it's slow because, well, it's slow. Another thing you can do within the dedicated SQL pool is data discovery and classification. Well, shucks, I messed up the text there. So data discovery and classification is going to allow you to mark specific columns as classified information, as sensitive details. This may be a name attribute that would be eligible for GDPR. This is a protected health information. You can create your own classifications, or you can use the ones that Microsoft provides you. Then you can build reports on who is accessing those columns. So if you define that these columns are sensitive, these columns are highly sensitive, you can see who's writing queries. You can see the specific queries that they're writing. You can see the counts of results when they do it and be able to audit any access. A good example of this is if you're in a medical system, if you're a nurse and you go look up some patient information, you'd better be assigned to that patient. If there happens to be a famous person in the hospital, you as a nurse don't just get to access that patient record unless you are actively one of the nurses on that floor working with that patient. And they will review these. They do audit them, and they do, in fact, fire nurses for breach of confidentiality, breach of privacy. This is a type of thing that you could do with data discovery and classification. Let's talk about the serverless SQL pool. Real high level, we still have roles. We still have logins and users. We can still grant, deny, and revoke permissions and set role assignments. But the serverless SQL pool is a little bit more lax in terms of its roles because that pool is read-only for the most part. There's one way to insert data into a serverless SQL pool, and that is to use CETAS, create external table as select. That's it. You can't insert, update, truncate, merge, delete. None of those operations work. The only right operation that works is CETAS. The serverless SQL pool is pretty much read-only. So we also cannot create normal tables because we can't insert data into them. I mean, my DBA manager would love that construct, but none of us would. We can access data through OpenRosette or external tables in Polybase. So OpenRosette, you need to have at least the Synapse User RBAC role, as well as something that sounds very impressive, grant administer database bulk operations. I hear that and I say, whoa, am I just going to give this out willy-nilly? And the answer is kind of. And it's okay because that's the only thing that they can do is run OpenRosette. On premises, grant administer database bulk operations is how you do bulk insert. In the serverless SQL pool, we can't insert, so there's no bulk insert. Really, it's just, here you go, you can query data. Polybase, you're going to need Synapse User. And to create or drop external tables, we need control permission. There's no way around it. Control permission is a very powerful permission. So that is powerful. Unlike grant administer database bulk operations, which just sounds powerful, control is powerful. I can now create and drop tables at will. If I want to read from an external table, DB data reader or DB owner will do that trick. Or you can grant select on the table explicitly. So if I need to select from an external table with Polybase, I just have to be Synapse User RBAC role, and I have select granted to that table. I don't need underlying permissions. I certainly don't need control. It's if I'm creating those external tables where I'll need those control mechanisms. One recommendation when you're accessing data through the Serverless SQL Pool is to use the Managed Service Identity account. So I create a database scoped credential, and I say identity equals Managed Service Identity. That way, I don't have to put in username and password. I don't have to put in anything special. Basically, I just say, Synapse, use what you already have. Use your low privilege, fairly decent account, and just figure it out. And it works pretty well. So then my external data source, I can connect to the data lake resource using my managed service identity account in Azure Synapse Analytics. As long as I have granted that managed service identity account, storage data blob contributor, I'm good. And that will usually happen automatically if you have sufficient permissions when you create the workspace. Otherwise, you can go into IAM for the storage account, go to that role assignment page and add the managed service identity account for Azure Synapse Analytics, the application account, as a storage data blob contributor, or frankly, a storage data blob owner is what it really should be, because you'll need that to write data to the data lake. If you do need to access external resources and you can't get to them through your managed service identity account, you could use shared access signature tokens, SAS tokens. These will give you limited access to specific account resources, and you can filter them down actually very effectively. You could say, I will allow you to access this file or these files or this folder or this container. I will give you permissions, list, read, write, delete for 6 months or for 1 day, 8 hours, 12 minutes, however time frame you decide. Only these IP addresses may use the SAS token, so that even if it's somehow exposed to the public internet, unless you're running from one of those 2 IP addresses, it still doesn't matter. And I can also require HTTPS access. I can create SAS tokens very easily. Here's an example using Azure CLI, where I generate a SAS token on my storage container. The SAS token is called Synapse, requires HTTPS, will give you delete, list, read, and write. That's what DLRW means. My expiration, I've set this as 30 minutes into the future. And my account name is my storage account name. I could go further and specify things, like I said, like IP address, if I really wanted to lock this down further. But it's going to generate a SAS token for me, and then I can use that SAS token and gain access to those resources. Spark Pool. Spark Pools actually do use SAS tokens a lot, by the way. The Serverless SQL Pool, like I said, usually we're going to use the managed service identity, but Spark Pools use SAS a lot more often. When you create Spark Pools, we have isolation. 2 different possibilities for isolation. Number 1, network isolation. It's in its own virtual network. Or let me rephrase that as, when you have managed virtual network enabled, each Spark Pool is in its own subnet. Physical isolation. If you use XXX large as your Spark Pool size, which means you're throwing gobs of cash at Microsoft, then there's a checkbox that will let you get physical isolation. Your Spark cluster is on its own server with nothing else. No other machines, no other VMs, no other Spark clusters, not even your own. It's just on its own machine. So if you got enough money to throw at them and you have a need for this, that's a checkbox. And you can get physical isolation. Otherwise, your VMs will be on a host, potentially with other customers. Not much you can do about it in a public cloud. If you're creating a Spark pool, you're going to need to be a Synapse admin or Spark admin. And to run a Spark notebook, you got to be a Synapse admin, a Synapse Contributor, or a Synapse Compute operator. And of course, if we actually want to use Data Lake, if we want to pull any data up from any place, storage blob data contributor on that storage account. Lake databases are a mechanism of tying Spark pools and the serverless SQL pool together. The Lake database is a way of exposing metadata to both environments. We create a Lake database at the storage level, and we grant permissions to the Lake database based on your permissions in the storage account. Database creator is the owner of that Lake database, has all of the rights for the Lake database. In addition to that, Synapse admins, Synapse SQL admins will have all permissions as well. Synapse SQL admins will be able to query it through the serverless SQL pool. Synapse admins can query it through Spark pools or through serverless SQL pool. When you're running Spark, it comes with a lot of libraries pre-installed. It comes with Python and quite a few packages. It comes with Java, Scala, quite a few packages for that as well. But you can install additional libraries after the fact. Synapse doesn't support Maven, and it doesn't really support Java package management, but we can install Workspace packages as jar files as part of the Spark instantiation process. We create a Spark pool, we're spinning up those nodes, we can have packages install at that time. On the Python side, we can run package installation through pip, which is an external process to reach out to external servers, grab packages, and install them for Python. Or you can store wheel files and import them that way, like you do with Java. We'll need storage blob data contributor as well. Custom package installation does introduce risks because we can have vulnerable packages. There can be bugs in packages, and a couple recommendations. One is if you're going to pull in public internet packages, then use versionless package specifications, meaning that you get the latest version of pandas, of scikit-learn, of whatever, PyOD, to prevent getting outdated versions of those libraries that may have vulnerabilities. And with data loss prevention, you are not going to be able to access external websites like Conda channels or Conda Forge or pip libraries that have all of those packages. So you would have to install the packages from Azure Data Lake Storage. If you're using SAS tokens, do not store them outside of Key Vault. Keep everything in Key Vault. Use something called the token library to access these secrets. And we're going to wrap up with additional tools. The big tool, Microsoft Defender for SQL. There are two components that are of real interest here. The first one is Advanced Threat Protection, which gives you alerting on suspicious events. Hey, it looks like there may be a SQL injection attack that just happened on your system, or somebody's trying to brute force log into your workspace. Vulnerability Assessment sends an email every week that says, hey, did you know that these resources are available to the public internet, or that you could check this box and secure this, or you're not using this, say, security option. Maybe you have something that is not as secure as it could be. They'll send you weekly emails and give you reminders and show you what you can do to make your Synapse workspace more secure. Azure Policy helps ensure that if you have a lot of workspaces across the world, that they're all consistent and that people can't go futzing about with them after the fact. Business rules are defined in JSON, can help you audit. Has configuration changed from what it should be? Did some admins come in and mess with stuff after the fact? And if so, what did they change? You could even deny those changes, prevent those changes from happening if you set the policy a certain way. There are quite a few built-in policy definitions for Azure Synapse Analytics, and there's a link to them right there. It gives you access to JSON where you can see them and you could implement them yourself if you wish. You can create your own policies as well. So these are just starter templates. So let's wrap things up. Over the course of this talk, it's been 1 hour and change. We've looked at ways to secure Azure Synapse Analytics, but I stayed extreme high level. I actually have an 8-hour training. It's a full day training on EC Council's Code Red. It is a paid training, so if you're interested in that, let me drop a link in here just in case. But I will say in that training, I do go into a lot of depth on the specific steps of what to do because I have a full day to do that. However, you could take everything I've got here, grab resource guides, and you could implement it all yourself as well. So you don't have to pay money. If you want to learn more, if you want to grab links, information to additional resources, or these slides, especially after I fix the typos and fix that one slide, go to csmore.info/on/lockdown. If you have questions, here is my email address. Here is my Twitter handle. Sometimes I'm on Twitter, maybe. But with that, I want to say thank you so much. I appreciate you sticking in here. And what pool do I recommend for data that's in flat files and EBCDIC format? Probably you're going to want to store that data in the data lake and then have some transformation process that puts it in a format that is going to be easily readable elsewhere. Once you have the data in the data lake and you've translated into a more easy to use format like Parquet, then you can read it directly from the serverless SQL pool. You could process it using Spark pools, or you could load it into a dedicated SQL pool, depending on how much your customer needs to access the data, how frequently they use it, and how regularly their queries are. Like, is it quarterly reports that they always run roughly the same query or the same type of query with different filters? Or is it ad hoc exploration? That's going to give you dedicated versus serverless SQL